take a look at today's quick example. Example number 1, given the following, 0 is greater than or equal to x squared minus 17x plus 70. We want to solve the inequality. We want to find the solutions using interval notation, and we want to graph the solutions on a number line. So the first thing that we're going to do is I am going to rearrange my quadratic only because it is my preference. So I rearrange it and I'm going to swap that inequality. I'm pretty much reading the inequality backwards. And I'm going to use my factoring skills to factor this. You can work with the inequality or you can change that inequality to an equal sign. So here I just left the inequality as is. I factored and I'm going to get my two possible solutions. And this time I'm actually going to just write equals. So we have x is equal to 10 and x is equal to 7. But this is not an equation, so I do need to incorporate the inequalities back somehow. So I'm actually going to skip to part C, which is the graphing portion of this. I'm going to label the two possible solutions I have. So I have, it could be 7 and it could be 10. And here is where I have to do test points. So I like to pick a number before the first x value. So I'll pick 6. And I am going to input this 6 or this x value into the original equation. So we would have 6 squared minus 17 times 6 plus 70 less than or equal to 0. And I'm going to do my evaluation, which would give me 4 is less than or equal to 0. Is 4 less than or equal to 0? No. This is a false statement, which is telling me that our solution does not lie on that side. I'm going to do it again for the opposite side. So I'm going to check 11. And I'm going to plug in that 11 into the original quadratic inequality. And again, I am going to evaluate. And again, I get 4 is less than or equal to 0, which is false, which is telling me that the answer is not going to lie on that side, which automatically by default, where is my answer going to lie? Somewhere in here. So I'm going to graph this by putting two open circles. I'm going to check the original inequality. It was a greater than or equal to, so this circle is going to be shaded in, and this one as well. And I am looking at all these possible x values. I can have a value of 7 all the way to 10. So now let's go back and let's actually state that. For our answer, we could have x is less than or equal to 10, or we could have x is greater than or equal to 7. We're going to merge this together because we only have that in between piece. So as an inequality, this would be 7 is less than or equal to x, which is less than or equal to 10. There's my solution. For part B now, we want to write that solution using interval notation. So for part B, using interval notation, 7 would be included, and so would 10. So I have from 7 to 10. Let's look at our next problem, similar process. So we have given the following, x squared plus 3x plus 2 is greater than 3 times x plus 2. We want to solve, we want to state the solutions using interval notation, and we want to go ahead and graph it. So let's start with the solving piece. Here, in order for us to solve, we're going to do distribution, and then we want to set it equal to 0. I'm going to move all of this to the other side, and I'm going to go ahead and use my factoring skills. At this point, I have my two possible solutions, -2 and +2. So I'm going to skip to part C again. I'm going to do my graph piece. That way I can visually see my solutions. Right now, I have, it could be -2 or 2. I'm going to pick a number below -2, which would be -3, and I'm going to plug it in to the original equation. So let's do that. I'm going to evaluate this side, and we get 2 is greater than -3, which is true. What does that tell me? That tells me that my answer is going to fall somewhere in there. Let's do it again for the opposite side. Let's pick 3. And we get 20 is greater than 15, which again is a true statement, which tells me that my answer lies there. So what we are going to have here graphically is we're going to circle our -2 and 2. This time, the circles are going to stay open, and we're going to shade all of this and all of this. So let's write our actual answer. We can have x being less than -2, or x can be greater than +2. Using interval notation, part B, what can I have? I can start with -infinity all the way to that first circle, which is not included, union, from that second circle, which is 2, all the way to +infinity. And that would be our solutions using interval notation. And that is all about inequalities.